Good evening, everybody, and welcome to class. Tonight we are working on Chapter 4, which is Unit 3. I know that's a little confusing, but the focus of the chapter is looking at Ruby as a language and some of the fundamental components of working with this language. And we are going to step through the exercises within the chapter. So as you work and follow along with the video, make sure you take your screenshots and do your narrative as per usual. The one thing I want to mention before we start out is and I often forget about this, issue that we sometimes run into. When you look in Unit 2 at the bottom, some of you may have gotten this error right here related to JavaScript. Now, one thing that I forgot, from semester to semester, because basically we teach this class just in the fall, and a year goes by and I forget all the things that we do. But we discovered that some people were getting this error and some people weren't, and I forgot what the commonality was. And the commonality is the people that have had a technology called Node.js installed on their machines tend to not have this issue. So one of my students was having that issue, did a little bit of research, and discovered that the solution is indeed installing Node.js. So if you actually go to the Node.js website and download this product and install it on your machine, in essence what it does is it replaces the JavaScript runtime in your operating system and uses this as primary for running JavaScript files. And it takes care of a lot of those issues. Now there are two versions that they have posted there, either version 8 or version 10. After looking at their documentation, basically from following this link, I saw that version 8 is going to be deprecated and going into maintenance mode as of April of 2019. So I just went ahead with version 10. I just figured it makes more sense to get the more current version. So if you want to install that technology on your machine, I would recommend it, and it would help you take care of that issue and without having to change any of the code that you need to do. Okay, so going back to the course shell here, back to Unit 3 and into Chapter 4, and I have the book handy here, so I'm going to jump right to Chapter 4 and start reading through. So one thing that we are going to do is we're going to learn about all the different types of command prompts that we have to work with in this language. And the one thing that you guys are going to discover is that Ruby is an interpreted language, meaning that we don't necessarily compile it like we would, let's say, Java or C++ or C#, where we turn it into binary code that's precompiled and then just runs. Ruby is in that category like JavaScript, that it runs one command at a time interactively on the fly. And that's a little bit weird because we also know that it's an object-oriented language if you listen to the earlier lecture materials or read in the book here. And we don't often associate object-oriented with interpreted languages. But the truth is that most good interpreted languages these days are also object-oriented, and JavaScript is actually no exception. So we are going to dig in here and we're going to learn about how this language functions. So the first thing that we need to do is we do need to bring up a prompt. So I'm going to go ahead and toggle over to my command prompt window, which I do have already open here, and I'm going to kind of shuffle it off to the right side, the left side of the screen. That's my preference for this week. And I'm going to kind of minimize the width here so I can kind of look at the text at the same time. It's kind of like playing with screen space and trying to find like a comfortable balance between font size and readability here. All right, the first thing that we're going to do is at the prompt, I do recommend that we drop down to the root directory. So I'm going to, from a user directory, type cd space / to get to the root. And even though I'm not really too particular right now about where I do my work, I would prefer to actually do the work in my blog folder, just because that's kind of my active project. So I'm going to go ahead and type cd space projects and then cd space blog. From there, I'm going to type the command that gets us the Ruby prompt. So this is an interactive Ruby prompt, and if you went through that online tutorial, which walks you through like all the Ruby basics, that tutorial basically gives you a Ruby prompt within it. So that, I mean, that's why it works. So we need, in this environment, we need to trigger that prompt. And to do that, we type IRB, which is interactive Ruby. Now, once you've done that, you can see that the prompt changes and you know that you're in that mode because it tells you that you're in that mode. So the other neat thing that it does, you'll notice, is that it kind of names and numbers things as you go, which is, I think, kind of fascinating. And if you think about, for example, about working with other interpreted languages. So, for example, if I bring up, any web page and do an inspect element, and then go to the console and inspect element, you basically have an interactive prompt here too. And I know that we demonstrated this before. So if I do math here and press enter, well, didn't like that one. You don't put the equal sign in, you just do the math, brute force. This is an example of an interactive prompt. And if you guys were taught how to do JavaScript by one of us here, chances are at some point you probably went to the console and played around with it. And if not, well, I'm giving you a heads up, you can. And not only that, but you can do some pretty creative things. In fact, I did this little session this past Friday where we brought in high schoolers and trying to get them excited about signing up for gateway programs. And as we had some screens up for them to look at from the gateway website, one of the guys got clever. He went into the console, injected some HTML onto the page with his name, and says, like Joe was here, in a picture he grabbed from the internet. Yeah, you can do that if you know what you're doing. So you can take a page that's already active and interject code right from this console. And I'm like, all right, this kid's in high school, and in fact, I think he was a sophomore or something like that. I'm like, hire this kid. He's already on top of it, and it takes some of my students like a long time to learn that. Anyhow, let's go back over to the book. We have our prompt, and we're going to start doing all these basics here, so please follow along, take your screenshots as you go. There are also other methodologies actually to capturing what happens at the prompt, and I'll let you guys research that on your own, but the command prompt here actually buffers the commands and the responses in a memory space, and that memory space has a limitation as to how much it holds. So if you don't want to take all your screenshots right away, what you might want to do is go into the settings here, and actually we'll go to properties, and right here on the options tab, notice the buffer size and how that's set. Right now it's set to 50 lines. So after 50 lines scroll through, it no longer retains like what you typed and what was responded. And you know what? You don't have to stick with that number. Maybe you can bump it up to 500 and it'll capture everything we do here tonight. And it's not going to hurt anything. It just takes a little bit of memory to store it. And there's also ways to take that buffer and save it to a text file if you're curious. I would challenge you to Google it and find it. It's not that hard to do. All right, so I just upped my buffer size, and that way if I run into anything that generates like pages and pages of text at the prompt, I can still scroll back and see it. All right, so our first little directive here is to type, of course, hello world, which we must do as programmers just to kind of wet our feet, right? And just like the tutorial that you had online, you put in a string of text, press enter, and it says, okay, I got it, here it is. I read what you typed. I'm not sure what good it is, but here it is. I mean, really, because we're not storing it in a variable, right? We're not like using it to do any action, but it'll take the text and give it right back to you. All right, so that's what that one does. You can also do the same thing we did in that tutorial online, and you can do some math, so you can go 1 + 1. And you see the response to that, it just assumes that you're doing the math and gives you the answer. Yes, so it can do math on the fly. Another thing that you have, and I know this was in that tutorial as well, is that there are built-in methods to the language, right? So I can say time, and by going .now, of course it pulls up the time that it is right now. So you can see that it is October 8th at 5:44 and 38 seconds p.m. And it also shows -500. What the heck is that? Yeah, difference from GMT. Greenwich Mean Time, right? So we are 5 hours behind Greenwich, right? That's actually the right way to say it, Greenwich Mean Time. I used to live on a street called Greenwich for a short period of time, so I should know that. It's not Greenwich, right? Greenwich, yeah. That's a green sandwich. That's the one you don't want to eat, typically. All right, their next example is time.now.year. And guess what that does? I mean, I know you can see it in the book, but it narrows it down, right? And do you think that if I type something like time.now.day, right? And you know what? You can guess at a lot of it. Well, today is the 8th. It is the 8th. Yeah. Yeah. I was gonna say maybe you're in Hawaii and it's not quite the 8th yet, right? All right, let's start talking about data types, and that's kind of a standard thing we do in a language. But so far, our example shows us that we can do math, we can throw strings at something, we can call up built-in methods in the language very easily, and there's lots of them. And if you're really looking, yes, yeah, you simply go to the Ruby site, and they actually have a listing. They have documentation. One of the things that we did when we did our install is we opted not to install all the Rails documentation, but this is Ruby, and the place to get the Ruby breakdown is at the Ruby website. Actually, there probably is. Um, in fact, Richard, I don't know what it is, so I'm just going to do this, and that didn't like that. So apparently I need to. Okay, so I have to get a syntax error here. Yeah, it doesn't like. It might just be like time.help. Yeah, every method will have a different way of doing it. Um, so don't quote me on that one. And at some point, they'll probably even tell us here in the book. All right, so Ruby does like to work with strings, which we already saw. So they have a different example in the book, but I'm just going to type Ruby likes strings, right? You can use double quotes, and you can also use single quotes. They work pretty much interchangeably. And as with most programming languages, the reason that's the case is to allow you to have a way to encapsulate quotes inside of other quotes. So there's a methodology for that. Or if you needed a single apostrophe or something of that nature, it gives you that capability. So try it both ways. The other thing that's going to happen is you're going to see this other little piece here where you might type a string and then add some code. So the example that they have in the book is they're going a £, and then a curly bracket, and then they're putting that command in that we typed from the prompt before, and then closing the curly bracket, and then closing the double quotes that holds the whole statement. And I know that that's like scrolling off the screen here, but if you get this scrolled over, sorry, but it just really does not want to go to the edge of the screen here for me. It's probably because of the way I'm. Just press enter so you can see the result. But you notice that what it does is it can take a mix, basically, of a string with a command inside. And really, whenever you see that £, it's a hash mark, right? So it indicates that we're kind of switching modes. And what you guys are going to see is that there's a lot of things that Ruby does where it hashes the code so that it can intertwine things together. So this is a way where I can take a string and interject some code and then pull that code in as a string, notice I didn't have to go through the process of converting the output to a string to put it on screen. It just kind of did it automatically. Where in other languages, you might actually have to add a little method that says toString, for example, to be able to do output. That's not the case here. Rearrange my windows a little bit. All right, in the now they do this with both examples, and the one thing I found kind of interesting about this example is if I up arrow and repeat my command but change my quotes to single quotes, you actually get a little bit of a different result. And notice what it does is if I use single quotes, it does not treat this as code. It treats it as text, and what it does is it puts in an escape character. So if you wanted to show, for example, in the output statement, what the command is for Ruby to do time.now as a hash, here you have to use single quotes around it instead of the double quotes. So there is a difference in output. So in a situation like this where you're interjecting a command like that, you have to use the double quotes in order for it to stick. All right. One of the other examples that they're using right now is, this is bottom of page 47, by the way. They have us in double quotes type Toronto, Canada as a string, and then they add this little extra method to it, downcase. Now, that's not like a typical method name for using lowercase, but you guys can anticipate what that's going to do. It takes away all the capital letters. Right. And then if you do their next example, which is New York, comma, USA, and of course here I am forgetting the quotes, right? Dot upcase, which is everything in uppercase. Those are pretty intuitive ones. You might not guess at that name though. And of course, if you want to concatenate strings, a plus sign is a plus sign, and that's pretty common in most languages. And I'm not going to take it any further than that. I think you guys kind of get the point. So you can concatenate just like you would in most languages. What's the one language you can think of that's an anomaly for concatenating? PHP is a weird one, right? In PHP, you always have to use a dot to concatenate. Always drove me crazy. Plus signs. Every language does plus signs, so that one is kind of intuitive. One method that they're showing also is if you take a word and you do capitalize. Of course, you got to spell it right because it's not capitalize, it's capitalize. And it just makes that first letter capital. That's all it does. So there's some common methods for working with strings. All right, so here's kind of an answer to your question, Robert. It says to get a list of the methods available for any object, call the methods method. So if I want to see what the methods are for time, Robert, Richard, yeah. There's your list. You got that memorized there? There you go. So look at all the different methods that are added onto that one. And I'll let you investigate on your own. All right, let's move on to the numbers section now. So in the numbers section, I have some, once again, some simple examples here. I'm trying to move this without having it attached to the side of the window. All right, I'm going to type my clear command, and actually on Windows it's CLS, or is it clear? Oh, we're in the Ruby prompt. I can't do that. See, I'm trying to put in a Windows command at a Ruby prompt. Not happening. All right, so let's do our math examples. We're just little 1 plus 2. We saw that already. And yes, you can take some pretty large numbers. Well, reasonably, you should say reasonable numbers and add them together. You should be able to easily do subtraction. And with it, I put in an equal sign instead of a minus, so let's fix that. But you can see what the syntax error is, so you don't want to use an equal sign here at all. Of course, if you want to do some division, interestingly, if you take a real small number, divide it by a real large number, notice the result here. And notice how we're not getting a decimal point. Right, but if I come back here and add in some decimal values, even if it's just 0, then the output will cast itself. Yeah, that's a small number, but right. And this is not unusual. Actually, even languages like Java will do this automatically, and it's a trick that programmers will use. So you have an integer, but you want to do some math, and it's going to be, decimal or floating point output. Right, right. So that's kind of like built into the language. So you have to know what you're feeding it in order to get the result that you want. Exactly. Exactly. That's right. You don't. That's correct, Richard. Just one of them has to be a decimal in order to make it happen. And they make a little point of it, actually, at the bottom of page 48 right here. So they show an example of like 6 divided by 4 is 1, right? So that's integer division right there. And all right, and then the second example, just by adding a decimal point to one of them, then you get the actual correct decimal response. So that's pretty important. All right, let's talk about this next concept, and this is one that will be, I guess, perhaps new, because this is a thing that we do in Ruby that we don't necessarily do in other languages, and the concept is called symbols. And I'm trying to think of another language where we really even use it, and we don't. We usually just use variables to kind of accomplish the same thing. But the example that they're giving is they type something like this, my symbol. And notice what it's prefaced with, and that is a colon, right? So by doing that, okay, so it reads it as a thing, and it gives it back to me as a thing, right? So you kind of think of it like that. It's just a thing. It's an object, okay? We haven't really defined anything to it. And then their next example is, well, what if you take my symbol and then add to it, yeah, and it won't like me either, because it doesn't have a way to combine those two things. It doesn't understand what it is. So it can't be treated that way. So I can't concatenate it like it's a string. So it's not a string, okay? And then they show an example here where they take two strings and combine them together without the little colon in front of it. And they do not, those will combine because they're strings, but this won't because it's not. Okay, so the question you should probably have is this. So then what is this good for? right? And basically what we use is we use a symbol um, to basically indicate an object and to be able to call upon an object without necessarily digging into the nitty-gritty of an object. We usually use it for something that isn't necessarily like a traditional type of object. So it might be like a mix of numbers and letters, or it could be a class file or a method or an instantiation of an object. Or it's a little fuzzy to kind of try to explain because what you're doing is you're pointing kind of like a pointer to something that otherwise might not be human readable is really kind of a good way to think of it. And if you look at what the book says, it says symbols are objects that work just like any other object in Ruby. They're used to point to some data that isn't a traditional string object in a human readable format. In fact, they're almost like strings except you can't modify them. Okay, so really what that means is you could take a block of code and assign it to a symbol. And every time you call that symbol, you're pulling the block of code. That's just one example. Or you could take some other type of object and throw it in. And it's really kind of a hard one to really point out without demonstrating at a higher level. So we'll get to the point where we are using those and you'll start to see them. But the one real key aspect of it is basically considered immutable, which means you can't change whatever the contents are. Whereas I was working with a string, I could, right? So we're just kind of dealing with it as it is and using it as it is without having to use all of it to do it. Okay, so it's a symbolic reference to something. All right, let's talk now about arrays and hashes. And you're going to see that defining an array in this language is actually relatively simple. So what they're using as an example is a thing called city array. So here we have actually the creation of a variable name where we're going to assign a value, so that's the equal sign. And as with many languages, we use square brackets to define our arrays. And this is going to be an array of strings. So I'm just copying what's in the book. So I have an array of strings, which are the names of cities. Then I'm going to close that. And once I press enter, it is now stored. If I want to look at that array, I can either use the whole name or, as in the example that they're pointing out, they're using square brackets with position numbers, just like any other language, right? So if I do that and then put in the index numbers for the 3 positions that we have, which are 0 through 2, it will spit back the city in that position. And of course, if I put in an array position that doesn't exist, notice what the response is. No, there's nothing there. All right. If I wanted to just output the whole array, I just use the name, and it'll tell me what's in it, which is kind of handy. If I want to add something to the array, here's an example. If you just want to append something to the end of it, check out this really simple little technique. This is how you append something to the end of an array, and then it shows you the result. So you just say city array, 2 left pointing brackets, and then your string. You can also, if you want, use what you would consider maybe more traditional syntax. And instead of the double brackets, you can just use a plus sign. And I didn't like that, so that's kind of interesting because, oh, I see. What did I screw up here? If I want to use the plus sign, I have to do this. I have to put the square brackets around it to show that I'm adding an array position. See how the logic works here? So really, in some ways, it seems like the preferred way is the first approach that we saw. But either way, you are adding it in there. So it does like this approach. So city array plus square brackets Los Angeles, and then it'll add it to the array. Of course, if I ask it now to repeat the array, what are you seeing? Yeah, it's not there. Yeah, one of them is not actually adding it to the array. One is throwing it in there temporarily. It's not really incorporating it. Is it double quotes? Or, I mean, if I put an equal sign in here, what would happen? The whole array would clear and just Los Angeles would be in there. Yeah, so that's not the approach. So if you want to add something to the array and have it stick, you need the double bracket approach. Okay. All right, so in this next little example, and this is where we actually start to see um, the symbols. Okay, and what's interesting here is really what we're building in this example, and I'm going to like maximize this a little bit so you can see it better before I type it in. I want you to notice that this next thing that we're creating is a hash. So whenever you guys are seeing curly brackets here, we're creating what they call a hash. And this should look, I should say, vaguely familiar to you in terms of a technology called JSON. Have you guys all been exposed to that technology? JavaScript object notation? Where in JavaScript object notation, we can give something a name, put in an equal sign, the curly brackets, and then comma separate key value pairs. And that's really what we're doing here too. But I want you to notice how the key value pairs are being presented here, how the very first key, if you will, notice what the precursor is to it. It's a colon, which makes Canada a symbol. In essence, it's making it a symbol of the key. Isn't that interesting? Yeah, so it's associating two values together, and then in a very Ruby-like weirdness, we say equals bracket. It's kind of like a little pointer. Yeah, it's an arrow. So let's go ahead and type this in. This is kind of weird, but let's go ahead and type this in. I'm going to copy paste it to save a little bit of torment here. Not that it's really torment, but so what I did just now is I defined my hash, and yeah, and what's kind of weird here is it is truncating stuff off the side of the screen, which I'm not really liking too much. And I really don't want to be doing what I'm doing right now. But you have to take it on faith that all of that entered in here, even though it's not really cut off that side of the screen. But it did output for me the fact that Canada is now tied to Toronto, France is now tied to Paris, and UK is now tied to London. And then if you look at the book example, when you go on to the next step here in the hash, so if you type, in this case, make sure I'm at the prompt, yes I am, and I type my underscore hash, and then inside of square brackets, colon UK, close the square brackets, it will find that association and tell you what its value is. Now I'm going to tell you this is a very simplistic example. So really what I'm doing is I'm setting up kind of like a variable name. It's really, and you know what? For me, it always helps. I just think of it as a variable. And this is used very much how in JavaScript, you can take anything you want in JavaScript, whether it's a number or a string or a function or an object or an array or you name it, and store it in a variable name and then just use the variable name to refer to that whole construct. That's exactly what a symbol is in this language. In JavaScript, we call them variables, and in JavaScript, the variables are so flexible they can hold anything. In Ruby, a symbol is that functional equivalent. So it's not really technically a variable. And the other difference to it is, remember what was the other key about symbols? Can't change the contents, right? So that sounds kind of like when you have a constant, right? or you have something that you don't want people to mess with. It's not like somebody's going to go take London and move it over to Ireland, right? So in this case, it makes sense for London to be attached to UK, right? Not that you couldn't change the hash. Like if I wanted to say Birmingham instead of London, I could go in and adjust the hash to say that. But in this case, what we're doing is we're pulling in that piece. Now, if you wanted to change something, and that's the next example here. So if I said my underscore hash and then say Canada inside there, and then put an equal sign after it, now I can attribute Calgary to Canada. And then when I type this command, it will give me Calgary. And then, of course, I could switch it back. And maybe I can make it Montreal. And then it serves Montreal. So it's not like it's not ever changeable, but in terms of how you assign it, this is the methodology for it. Now, the fascinating thing is there's a bunch of methods, of course, attached to these structures as well. And when you start to think about the hash as kind of the format of a JSON object, because it's really kind of what we're doing, because it is a value and or a key and some sort of a value, or a symbol and a value that goes with it. They're often kind of really in the structure of an array, in value pairs. In PHP, we call this an associative array is really what it is. And when you think of it in that context, where instead of using index values for each position, you are using the name of the key for that position instead. So you're customizing the index number is really what you're doing. Then all the array type things that you might do, including, for example, like my hash, which is the next example. And if you're looking for the first value, right? Right. Oh, interesting. Yeah. You guys caught me. Is right? Because I did type Canada lowercase before. And actually I copy pasted it, so all the countries were lowercase. But and I guess if you can figure out like if there's first, I can also do last, right? Mm-mm. No, not at all. Can't do that one. No, you would actually have to like look that up. But what they do show you what you can do is this. Yeah, I added one. That's what I did. Well, Nathan, the only way to really find that out, yeah, it doesn't. Whatever it is, it doesn't like it, right? First works for some reason, but the other ones don't work for that one. All right, so we did the keys. Next thing that they're going to show is an array, and they're going to do one with numbers. So let's move on to that. Numbers array. And in this case, they're just doing this. 1, 2, 3, 4, 5. Close it. Pretty simple little numerical array. And then they want you to do this, which I'm going to, and compare them as structures. And what's fascinating about this approach is how they're kind of similar, but they're kind of not. And really, if you keep that thought of the associative array or the JSON structure in your head as you work, that's really kind of the difference between a hash and an array. And with this, I actually have to think about what I'm typing. Isn't that tragic? Okay. So here we're establishing that key value pair or the associative array one more time. And yes, the two are different types of structures. So there's places for both, and it really kind of depends on, programmatically what you're trying to accomplish. But this gives you a way to basically have kind of like this kind of like primitive data storage mechanism in place where you can pull up values, you can assign different values, and then utilize them within your program without necessarily having to commit them to the database on a permanent basis, right? Or write them to a file, although you could do that as well. Okay, next thing they're going to demonstrate to us is how in this language, as in JavaScript, you can put anything into a variable. At first, it could be a string. So I created something called test variable that's a string. Now I'm going to make that test variable a number. It'll do that too, it doesn't care. In JavaScript you can do the same thing. Try that in Java, right? You're going to break it. Try that in any strongly typed language, like what we traditionally learn first, and it's going to just break, right? But from a conceptual standpoint, Java is really flexible. Or JavaScript is really flexible, right? It says, well, yeah, okay, switch it to a number. That's fine, whatever. It's just data, right? So there's automatic tools built in, so we don't have to worry about conversions and changing or declaring data types. And then, of course, the other example is if it had decimal points to it, that can change. So we went from a string to an integer to a floating point number, just like that. And then when you think about like JavaScript as the comparison, in JavaScript, the other kind of stuff that I can put into a variable is I can put a function, right, into it, or an object, or you name it. Anything in JavaScript can go into a variable. That's not quite true here. And in a lot of those situations where it's like the anything that goes in, we use the symbols as opposed to the variables. And hopefully that helps to clarify that a little bit more. Now, another thing that's kind of special here, and you know what, we'll do this little tidbit and then we'll do a 5-minute break because I think we're at a good stopping or break point, is I want to look at this little chart here to show you another really important construct that's kind of weird inside this language. So first of all, let's skip the first two and go right to the second or the last two, and notice that you can create constants in Ruby by capitalizing the first letter of a variable. Okay, you guys catching this? Because that's sounds like something I might put on a test. So you don't have to say constant or const or final or anything like that like you do in other languages. You just make the first letter a capital. However, the convention in all programming is that you do all uppercase and logical words are separated by an underscore. People have just done that forever so that whenever you look at somebody's code, you can quickly figure out if it's a constant or not. Right? Does it mean you have to do it that way? Absolutely not. But that's the convention, and most programmers do tend to follow it. Okay? Notice this little caveat, though. In Ruby, constants can be reassigned. However, you get a warning from the interpreter if you do so. So you can actually change the value while a program's running. It's not really considered good practice. Regular variables, all lowercase is kind of the convention. The other convention that you'll see in Ruby, and they haven't really talked about it a lot yet, is the convention is stick with all lowercase, underscores to divide logical words, and overly verbose descriptions of what it contains. So if you have a variable that holds interest rate on Monday, October 8th for prime rate for checking, you might actually have a variable called that. Why? Because it's very specific. And when you look at it, you know exactly what it is. And that's just kind of like the convention in modern programming. And this language really pushes that pretty heavily. So whatever it is you're naming and storing, name it what it is, be verbose. All right, let's go up to the top two now, which are the weird ones. Now notice the first one, two @ signs. Anything that starts with two @ signs is considered a class variable. Okay, so yeah, so notice what that says though. It says class variables exist in the scope of a class, so all instances of a specific class have a single value for the class variable. So if I have a class that I instantiate 100 times and I got a variable in there that stores, I don't know, my birthday or something, that variable will be applicable to all instances of that class. Okay, so that's a class variable. All right. The second one is an instance variable, and notice that has a single @ sign in front of it, and that's unique to that certain instantiation of that class. Okay. Now the thing that's kind of fascinating about that is as we start to build our blog application, you guys are going to notice that sometimes we'll be working with something called article. So for example, like we might instantiate one article out of our database so that it appears on the screen, and that'll get stored in @article, and it will be unique to that instance, right? So you will start to see that. So when you see that, you got to keep in mind that it's tied to that instance only. On the rare occasion that you see two, that's one that comes from the parent or the superclass that becomes instantiated with every instance, right? So unless you guys get object-oriented program, that's not going to make any sense. That's why you have to know that stuff before you come in here. But that happens a lot on the fly here because a lot of the applications that we build the structure and then we pump data into it. So of course it only exists in the instance. So you will start to see that @ sign in a lot of the code that we're putting together, especially as we pull things from a database and start pumping it onto a page. All right, folks, let's take a break. We're pushing on the halfway point here in the class. Let's do 5 minutes, and we'll move on. All right, we're going to continue on now. We are at the top of page 52, and we're going to talk about some more language fundamentals here. Pretty standard with anything that we're talking about. I'm sorry, I forgot to put the headset back on, so that first part was a little quiet. But we're going to start talking about operators that can be used inside this language. Notice that some of them are used for assignment. So the first two, you can actually use square brackets to do an assignment statement. All right. So in combination with equal signs, but the equal sign, of course, you've seen it already used, can be used on its own as well. For math, we're using all the standard operators. So we have the ability to multiply, divide, modulus, and then what do you think that last one is with 2 asterisks? What would you guess that one is? To the power of is correct. And now most languages don't handle powers that way. Some do. I think of like Visual Basic, how Visual Basic would use a caret symbol to do powers, where a lot of other languages you have to like call the math library to do a power. So this one allows you to do that. We also have the standard comparison operator. So if we are seeing here greater than, less than, or equal to, etc., those are pretty standard. Those are typically going to be, when we're comparing values to choose in a Boolean way what we're going to do next. So if we're testing a condition, typically. We also have these range operators, which are kind of weird. Now I want you to be really careful as you look through the book, because sometimes they do have code and they do go ... which means end the rest of the code. And that's not what this refers to. So what this refers to is something much different. So there should be an example down below of range, but basically it shows you that you're working within a range of numbers from this to that. So keep that in mind as you work. Notice that you do have ands, ors, or regular ors. And notice that they have an exclusive or, and I don't know if you guys ever even studied that. Most people, if they do study exclusive ors, they do so very superficially, but some languages do have structures for that. So for example, if you may have learned Visual Basic as your first language, you know in that language you can use the keyword or XOR, right, which is the exclusive OR. In this case, you can use a traditional AND or the regular OR, which is what they call the bitwise OR. The exclusive OR is actually one that forces a short circuit, is really what it does. And that way it doesn't process the whole statement, it only processes a portion of it. Now, the way a lot of modern programming languages work, like for example Java, it kind of does that automatically. It's kind of in the mechanics of the language, where here you can kind of force it. So what that's telling you is it doesn't really do that automatically on the back end. You have to actually force it if you want to make it more efficient. You can also use these operators. Now notice that, and this is true in other languages as well, and this is true in Java, and a lot of people don't realize it, because when you're working in Java, for example, you just kind of assume that you have to go 2 pipes or 2 ands to do an OR, but the truth is you can use a single one too. And a lot of people are not aware of that. This language also allows you to use actually the words. You can say not, or and, which just shows you that it's highly flexible and adaptable. The other thing that is happening out there are what we call the ternary operator, which we are now seeing being included really in many languages. And I don't know if you guys have been taught this or not. If you took any of my classes, I certainly take time to mention it. But we have this like really short little way to do if-else statements. And the way that the statement works, and this is actually the piece, right? And I'm actually going to highlight that. So the first part, the expression, is whatever you're checking. So you might say, you know, does x equal 10? You know, that might be the expression. And then the question mark is kind of like, well, if that expression on the left side of this question mark is true, then do directly what's after the question mark, and you can see where it says value if true. Then the colon, which is technically the else, right? So what this is really useful for is single little statements where you don't have a lot of code nestled in between. So if like this is true, then do this. If that, otherwise do that. Just really quick and simple. And you're seeing this being now included in most major languages with the exact same syntax. So you see it in PHP, you see it in Java, you see it in C++, you see it in C#, you see it in JavaScript, et cetera, et cetera, et cetera. And this is called a ternary operator, which is basically an if then else in a very simplistic format. As an example of that, notice here we're setting A to 10, B to 20, and then our expression is if A is greater than B, which is what? False, right? So we would skip the A and go to the false part, which would be the B, which is the 20, so the output is 20.
So the question mark would be an if.
It's not really, it's kind of like the, you know, like the if is implied.
Yeah.
So it's like,
you know, saying if, but the question mark is the statement.
it is, it's if and then is really what it is. Normally we're used to seeing the if before the statement, and in this case we're saying here's an expression that can be true or false. If that's true, then do what's right after it, otherwise do the other thing.
Else.
Right. Now this one takes a little bit of getting used to if you don't see it a lot, but you see a lot of modern programmers are using this, especially when it's simple little equations like this, because it streamlines the code. I mean, it saves you like 5 or 6 lines of code, really, you know, depending on how verbose you are with how you state things. So this is a really common way, especially if the whatever's in the then and whatever's in the false or the else is a really simple statement. So why have a really complicated structure when you're just doing something quick? All right, let's move on to loops. And actually, you notice that the title for this section is blocks and iterators, right? So got to name it something different. But notice that this first statement, which if you want, you can type this into the prompt if you'd like. In fact, I would encourage you to. if you want to see it in action. So let's go ahead and bring the prompt back up on screen here. And you can see we were playing with a bunch of time stuff during the break. But we're going to go 5.times. Guess how many times that loop is running? 5 times. Yeah, right, 7. And then you guys have saw this command when you were doing your other tutorials, the puts command, which is the equivalent of like an echo or a write line or a print line, right? So 5 times, and there it is. Yeah, it is very simple. And this is really the equivalent of a for loop. And instead of having to worry about setting a loop counter and an increment value or decrement value or a test, this is just a brute force, we're running this. Might not always be the case, but it just shows you how actually simplistic it is to kind of do the action. Now this next one that they demonstrate, and I'm just going to copy that whole thing, slightly different syntax. So you see we got 1, 2, 3, 4, 5. It's all an array. And then we do dot each. So what does that sound like? It sounds like a for each loop. So for each item in the array, we will take the item and put the item. So this is kind of like the variable. All right. It's just going to display 1 through 5. That's what it's going to do. So if I press enter on that, that's exactly what it does. But what you're seeing is the fact that it is basically it's a for each loop, and there's a secondary syntax. So what is it that it's putting? It's taking each item from the array, and as it grabs that item, we're sticking it in between pipes into like our variable kind of in the structure. That's kind of the weird part here for me, is those pipes around that item, because that's like, you know, if we were using a typical for loop, we might say for I, you know, for each thing that gets into I, and then I is the variable that gets the content that then gets put out. So we're saying for each time item receives one of these values, then we're putting item back out on the screen. All right, here's another one, and what I want you to notice on this next example is the fact that at the Ruby prompt, when we type in a command, and that command is not yet complete, and this is what I think is kind of interesting, is watch as I paste this in. I grab the first line, I'm going to paste it in at the prompt, right? So it tries to take the whole thing, but notice now how there's an asterisk right here. That means it recognizes you don't have the whole thing in here quite yet, sir. So keep giving me more. So what I do is I grab the next line, so one line at a time. It still, yeah, and right now I'm actually back to a regular prompt, right? And I actually think mine is not working right now, if you'd like to know. But once it sees that end command, then it stitches the whole statement together. So I could try to paste this all in at once, but I'm going to tell you right now, it doesn't always read so well when you do that. But you could type it all in manually, and yes, you could put the indents in there. But what this is basically doing, if we look at what it does, is we have an array of strings or characters, right, ABC, and then we're basically doing a for each, but with index. So we're indexing those values, and then notice the keyword do, that's our iterator basically, so we're running a loop. And then what are we passing? We're passing the item, so A, and the index value, or 0. So when you look here, you see item A, index 0. Item B, index 1. But notice that when you get inside the loop, what are you outputting? It gives us a string of text, right? And then it grabs the item as a variable. And because that's coming in as a variable, that's where we're using the hash and the curly brackets to pull that in. So we're intermingling it into our string. So for both the item and the index number. And then we're just doing one where we're just putting ... up on the screen. In fact, I could make it fancier and, you know, I can't do that here, can I? But if I were to repeat the code, I could retype it and make it something else. All right, so that's just a really simple example of a loop. Now, if you need to do some more sophisticated things with loops, I have every intention that you guys would go out there and figure it out. So this is just kind of an introduction to it. The thing that's fascinating about it, though, is because there are multiple statements here, that you do need the end keyword to end the structure. And when you're writing this out in a code file as text, you know, so, you know, regular Ruby file, you do want to do the two-space indents because that's considered mandatory in the structure. All right, next example focuses on control structures. And what's neat about this, folks, is they're assigning the output of time.now to a variable. So we just took that and we stored it. So if I type now, you can see that it's stored to the second. So now every time I do that, the seconds aren't going to change. Whereas if I type time.now, right? But if I type now, because I stored it in a variable called now. So it's stuck in time, in essence, right?
Time is stuck in time.
Time is stuck in time. All right, but if you take this next series of statements here, and you can try, I'm going to give it a chance here of copy pasting it, and I think I see a typo in there. I don't know if you guys are seeing it. But notice what I did. I pasted in multiple lines, and it says if now equals time now, which it's not going to, right? We would say puts now is in the past. Does that make sense to you guys? Else, if now is greater than the time now, which it will be, it should put nonsense. Otherwise, it should say time is past. Yes, time has passed, but the output is nil. Does that make sense? Do you know, why is it throwing nil at me? What's wrong with the code up there?
Oh, Elsa.
Yeah, there's a problem. There's a problem with what we're pasting in. So, and the problem with this is if I'm to repeat that whole statement, we get to that one line, and really, you know, here the shortcut way of doing it is like this. You know, paste this part in. Paste this one in and fix it. Still got the same output though, right?
Yeah.
Interesting, right?
Why if Elsa is add instead
Question, Nathan. Yeah, I do. I do. Shouldn't now be greater than time now? No, it can't be. Can it? Because if you stored it, it will always be in the past. So this middle condition will never hit, regardless if the syntax is right or wrong. Correct? Right. Because now we'll always be stuck there.
Now it's present.
Yeah, and of course Doctor Who premiered yesterday, so we got that in the mix too. So, all right, another thing that's kind of fascinating here is see the stuff that's on this page right here. Where you have A equals 5, B equals 10, puts B is greater than A if A is less than B. Does that even make sense? What's that? Well, if you're assigning values, they sure do. So if I say A equals 5, B equals 10, right? You can see it's giving me back a value, so it's reading it just fine. And then I just put in a command, puts B is greater than A if A is less than B. And is that true or false? It's true, so it should do that. But then if I say puts A is greater, if I can type, it is. It's a form unless A is less than B. So the output should be nil because that's not the case. So unless is also a keyword. Isn't that interesting? So that's kind of like, so what would be the functional equivalent of the keyword unless?
Else.
Yeah, it could be the else, or you could think of it as if you're checking a statement and you negate it. So like if you had like A is less than B,
Yeah.
put it in parentheses and then say not A less than B, right? It's just a different logical way to say kind of the same thing. Okay. So if you look at this next little tidbit here, where they have A is 5, B is 10, those are already stored, right? So we should actually be able to take this whole statement, hypothetically, and notice how this is just looks like a regular while loop, right? But so what should it do? It says, while A is less than B, which it always will be, put A, and then A is,
It's going to conceptually add 1 to A every time a 1 gets to B because it's going to be less than B.
right. So you can see that the plus equals, right? Like kind of like the hot wired increment thing works here as well. And so it is going to increment A once each time and therefore raise it up. And every time it loops through, it reads what A is into the string and just puts it up on screen. Pretty simple little example. But really what you're seeing is kind of like a combination of how the code works with itself and how we've done loops. A combination of both while being able to test conditionals all in the process as well. All right, we're going to move on to the next section now, which is talking about methods. And in this language, when we name blocks of code, singular, we are calling them methods. Other language, most object-oriented class-based languages tend to call them methods. Just so that we have like a common basis of comparison. There are languages, although like JavaScript, where we call them functions. There's also languages like Visual Basics, where we call it like sub-procedures or functions or subroutines, etc. So those are all things that you need to kind of keep in mind. But here we call them methods. And the standard structure of a method, as you see up on the screen here, is that you use that keyword def, right? So what we do is def stands for defining something. And in this case, we're saying time as string, right? And notice the verbose language here. And then we're putting the second line here, which is just time now. And then we're going to put in the method that is to_s, which converts it to a string. And then we're going to type in the keyword end. And as we finish, notice what it outputs.
Time as a string is string.
Not as a string.
So the object
It's in an object. Very good. Excellent. So notice the colon in front of it. So now that it's defined, we're we're using that as a symbolic reference to this method, right? So in a way, the colon in front of something is kind of a variable. This is what I was trying to explain before. Like in JavaScript, we just call it a variable, stick whatever in there. Here, because it's a more complicated structure, we're attributing this whole block of code. Now, granted, our block of code has one line inside of it, but it could have 100 lines of code, right? So that symbolically would refer to all of it with that one name. Now, in order to use that, here we're going to say, output to the screen here, time as string, and it does it. Now, if you're like me, you're like, why does it say nil at the end? Right? Well, it output what we needed it to, and nil just means that we didn't basically interface with it. We just used what was there, so there's no output or anything changed, really. It's just outputting what was there. We want to try the other one, where we're defining a method called say hello to, right? So, and notice now with this one, we're actually going to pass a parameter to it. So we're say hello to name. So now this one's going to need to have something passed to it in order to work. And then our next line, of course, is going to be the generation of the string that's going to be output. So we're going to say hello space, and then whatever name we send to it, of course. And then, of course, we will end the method.
And so now what that # curly brace name does is it allows any input name, and it will output that name.
That's correct. So when I call the method and I say puts, say hello to, yeah, and it had, and I thank you for correct. It has to be in the form of a string too. So pretty simple. Now you could see now as goofy as that is, right? That's a really goofy little thing. But could you see like if you're creating a website where somebody logs in, that you could easily just throw this method in, and then after they log in, you just put that at the top of the screen. Hello, Nathan. And in fact, a lot of websites do that. And you see how simple it is to do? It's like painfully simple, and works really well.
I freaked out a classmate by having a JavaScript file open. I asked them to test my
All right, let's move on to the next section, which is about classes and objects. And we got to remember that even though this is an interpreted language, it does have full object-oriented capabilities to it, which is one of the reasons why it's been so favorably received. And most modern languages have this as kind of a given these days, I suppose. But if you are familiar with the whole concept of object-oriented, right, the concept that we have a class file that defines basically the blueprint for creating an object, and that the object is the actual instance of a creation that is unique based upon the class, right? So that whole concept of a blueprint and then the actual thing that's created from that blueprint. All right, so that I'm assuming you guys have that firmly in mind as we work. But the thing that's fascinating with creating objects is you kind of do it on the fly in this language sometimes. So for example, the fact that they show like this rowing team, right? And if you want, I would go ahead and type that in. Yeah, and it didn't like you, right? And the why? Why is that? Because of that dot dot dot?
Yeah, it doesn't like that.
It doesn't like that. Because what that's really implying is that there's a whole bunch more. And see, this is the thing I was trying to point out before, is here we're not actually indicating a range. What we're indicating is that there's more entries. That's what we're indicating. And it works just fine. And that's exactly what I was going to ask that you do. So if you do paste that in, I'm going to like widen the prompt here just a little bit so we don't have to, it still loses it. And then just close it with a bracket. And if you wanted, you know, I guess hypothetically what you could do is you could add another entry here if you wanted, right? So the dot 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 means that you would have many more entries, but really this is a multi-dimensional array. So it's an array filled with arrays. All right. So back to the prompt. Press enter. You can see that it stored this. So we have two arrays stored inside of an array. And then, of course, if we, and I didn't want to do that, I apologize. If we issue the command where we, here's that command again, rowing team first, and it pulls back what? Not the first thing in the array, but, well, actually, it is the first thing in the array. It's an array that's in the first position of the larger array. Yeah, it doesn't have second, unfortunately. All right, another thing that's kind of interesting, and I'm not going to bother typing this in, but I just want to show you this conceptually, is now we're starting to see here kind of like this JSON style of approach in terms of being able to take multi-dimensional arrays, assign them to a symbol. That's what's happening here, right? So you see this, the symbol name for rowing, which is the same thing that we had before. And then we have another multi-dimensional array with a symbol name for track. So these people are all in track. So some people are the same, some people are different. All of that goes inside a comma-separated list inside of curly brackets like JSON. And then that's all applied to the keyword of teams. So now we're starting to see kind of this parallel with how we work with JSON data and JavaScript kind of coming into this realm. And really what's happening here is the differences between this and JSON, in essence, is the fact that we have that symbolic language, that colon in the front, to indicate that that's the key for that value that follows the equal bracket. And really, when you think about it that way, if you just eliminate that colon and eliminate this symbol, you really are looking at JSON data, folks. That's really what you're dealing with. It's just how it's done in this language. It's just the parallel. So that's really powerful, because really here we're giving it one variable name, and inside there, using symbols, we're able to extract a significant amount of data with using a minimum of words. All right. Let's now talk about classes. Classes in this language are not too dissimilar from classes in other languages. Once again, it will define a blueprint for something that will later be instantiated as an object as the program's running. So notice that we have a class named student here, and for that student, we will also have what we think of in other languages as data fields or private variables inside that class. And notice that we have kind of in combination here, really, the definition for the private variable and then the setter and getter methods for it at the same time. Now you notice that we don't just have a declaration that says first name, or and then we put together a getter and a setter for it. Here, by creating the getter or the setter, you're also creating the variable at the same time. And if you want, and you know, with any programming language, you don't have to have getters and setters for everything. Sometimes you just have setters, and sometimes you just have getters, right? And you should be aware of that. But you know, the standard is we usually do both. But sometimes you want to lock out one function or the other. And this is how we do it in this language. And what I want you to notice here is that when we run the method, we are defining something, and then we anticipate, if we're setting something, that we're going to be feeding it a value. And then where does that value get attributed? To the instance of this. So when it is actually instantiated, it is instantiated with the @ sign in front meaning that it gets attached to the instance variable right there. Notice that the getter is going to pull it back not from this structure, but from the instance once again, and it's just pulling the data back, and it's not necessarily setting anything to it. So this is how we do getters and setters in this language, and also the definition for the class at the same time. That's pretty interesting, actually. All right. So now that we have that object hypothetically created, and you notice that at this point I'm not really even typing in the code because really this isn't the ideal format for doing it. You can come in and start to define these things. If you want, I'll tell you what, there is no harm done if you take this code, because what you guys should ask really is like, Ty, can you type that in so I can see you actually do it, because I don't believe you? Can I just type this stuff in at the prompt and will it work? And the answer to that is actually yes. So even though it's in this format, and I don't have, notice the indents that are required, but I could. But I know that the interpreter will read it just like this. So yes, I can take all this code and I can go to a prompt. Notice that? Paste it in just fine. Press enter. And it stored it. So now we can take this and start typing in these commands that you see here. And I'm trying to be careful with my screen space here. All right, so the first thing we're going to do is we're going to create an instance of student. And are you guys noticing, what did we call the class? You notice how it's class with a capital S? You guys noticing this? But you notice that as I'm instantiating it, the instance is called student. So I could have named it chopped liver. You know what I mean? It doesn't matter what, it's just a name. But I chose to call it the same name as the class, or I could call it student one, for example, but this is an instance of that class. Where it actually becomes defined as an instance of that class is after that equal sign, where I just say student, which calls upon the class, and then I go dot new. Okay. So now it created a new student. Now, it doesn't have any information yet in it. It created it, but now I need to set and get all the values. Okay, so we created an object that has none of the values in it. So that's why we need the subsequent lines where we're going to say student dot first name. And where is it getting it from? It's getting it from up above. It's getting it from the defined getters and setters inside there. And that's going to be equal to Bob. Do the same thing with last name. And they call them Jones. And then if we want to output the whole thing, we call upon the instance, whatever we named it. Oh, thank you, sir. Calling on the instance. And then we say full name. And that's a dot in there. And then what that does is it calls the method inside the class. And you can see it right up above here, right? So if I call the method called full name, it just takes the last name, concatenates a comma, and then the first name, and puts those two together. So by calling on that, I'm calling on the last name, comma, first, and it outputs it to the screen for me. So see it on the fly. Yes, it's interpreted. I did it all from the prompt. And that's really kind of cool, actually. Kind of cool that it works really pretty simply like that. All right, let's move on to the next little example here. I want you to notice that there is this little thing that we can add here to it. And what this is allowing us to do is define, in essence, the attributes at the top of the thing. So here is the part where we're adding in what you guys are more comfortable with, and that is, like, think of Java, for example, or think of C# or just any other programming language, where we typically will define the variables at the top, right? Declare the data type, maybe preset a value, and then we run our getters and setters to drop everything in, right? Now what's happening in this example is we're kind of stripping out that capability where we're doing it in the standard format of getters and setters, and here we're just saying that the attributes or the data fields, if you will, for this class are first name, last name, and ID number. So we're actually adding a data field here. And then when it comes to outputting the full name, well, that's still going to be the same. That's the same method, right? Here. In fact, the way to really make this happen is, since this already exists in memory at the prompt, we're going to rewrite it. So we're going to drop this in just like this, and I'm hoping that's okay. I always get worried when I see that, it gets truncated like this, that it's not going to be okay, but usually it is. So what we did is we redefined the class, and then what we have available now is we still have first name and last name available, and a new one called ID number that we can still apply values to. All right, so what they're going to do next, and see, this is where we could still check this out. So for example, I could still say, if I were to repeat some of the previous commands, if I were to say student new, okay, so there's a new object, and then student first name, let's make sure it's different and say Joe. And then we could say student last name, I don't know, Smith or something like that. And then we say student, what am I missing here? How about puts? So you see it still works, right? In fact, I could also say student dot ID number. It's a new field that we added, equals, I don't know, 1, 2, 3, 4, 5. And then I could say puts, well, somebody's catching on here. So you see what it's happening here is they've come up with a different way, and kind of the equivalent, and I kind of trying to underline that, I guess, a little bit, is I think of C#, right? So I think of a language like Java where you learn how to do your getters and setters manually, and then you find it a revelation when you figure out you can right-click and generate them automatically, but it still writes out all the code, right? But then you go to a language like C#, and you put in a variable, give it a data type, and then you curly brackets, get, set. And all the getters and setters are automatically generated. This is the functional equivalent here of a shortcut method. So what it's saying is the attribute accessor, those are your data fields, and they automatically have getters and setters. You guys seeing that? All right, so when you start to see that in code, that's what that's referring to. All right. Now the next thing that they do is they go through and they build this class for team. Now you have to keep in mind that somewhere up above, you know, we had some other structures put together, right? And we're going to put this class here, provided I can copy paste it nice and cleanly like that. Sometimes it works and sometimes it doesn't. And it seemed like it copied them just fine. But let's take a look at what they're doing with the code before I press enter at the prompt. All right, so we have two data fields we're defining. One is a name, one is students, plural, right? We have a method that does initialize, and that one grabs a name and takes that name, assigns it to the instance, and then it creates an empty array of students. Okay, remember, at students, that's just a name. It doesn't imply that it's necessarily attached to the other one, but that is what they're going to do. And then with this next one, they write a method that says add student. So if I want to add a new student, I feed in the ID number, the first name, the last name, and then it goes through the process inside that block of code.
And then you got the add students and view.
That's right. So notice what it's doing intelligently is instead of putting it directly into the instance variable, it creates a local variable to hold it temporarily that creates a new student, gives it an ID number, first name, last name, and then takes all of that, and remember this symbol, how it adds it to that array structure? So it adds it to the instance of student that we declared up here. Then if we want to put it out on the screen, we just say print students, and then it will go through, and for all the students that are listed inside that array, run a loop, so a do while loop, as long as we have students, put that student full name on the screen. Okay, so I'm going to come back to the prompt now and press enter. Okay, so now we have that in place. And then we can come in here and we can try some of these commands that they have here. So the first thing we would do is we would, I'm going to change the size here a little bit. And we're going to say team equals team.new, and we're going to give it a name. We're going to call it the rowing team. Okay. Now we created it, and the reason it gives us like storage that at the prompt and start to say things like team add underscore student, feed in the parameters in the order that it would like to receive it. And yes, I'm just using the exact same stuff that they have, John Smith. So he's a member of the rowing team, and we just added him. And then I want you to notice how the output changes here. So the object is still being built. We got first name, last name, ID. Notice that they're all attached to instance variables. Isn't that really cool? It is really, I mean, it's a very different approach. And then of course we're going to run that same thing again, and we're going to, you know, we're going to have Jones and Smith here on the team. Very creative names with a different year, so we know that actually changed, right? And we're pulling up the method, and then this is hypothetically going to output all the people that are in the array, and it did. So that's the output right there, so it worked. So I know that if you guys never had object-oriented before and you came into this class and this is your first introduction to it, it's like mind blown, right? No idea what I'm talking about. But I have this assumption you guys all get object-oriented programming, and what powerful thing we just did here pretty quickly and simply, and kind of uniquely in a sense. So a lot of this is just kind of planning. Now, would you sit down and necessarily write code like this if you're building a web application? Perhaps not, okay? But maybe, right? Maybe. And it's also an indicator that you can actually use this programming language for stuff other than actually creating web pages. You don't have to create web pages with this language. It's just what it's most often used for. But it is a full-blown programming language that you can use for doing lots of different types of work. And you can see that it actually can interface with data and object-oriented concepts very easily. These classes that we created, they're not stored. They're not stored in a file. They're just existing in memory right now on the fly. So as soon as I close this command prompt, it's all gone. Right. Now, if I wrote them as text files and included them in an application structure, like in a folder, basically, that can be replicated. And right now, we're not tying this into a database, but we could. So that's really kind of the interesting thing here, is to have an interpreted language that really has some capabilities that, like JavaScript doesn't have, for example, at least the original version of JavaScript. Not going to change that because we were just talking about Node.js, which can interface with databases, but typically, like a language like JavaScript wouldn't be able to. But here, we're seeing a really easy integration, especially when we get to the database chapters, where we have this whole abstraction layer that sits on top of it all, and it all works so beautifully and seamlessly with a minimal amount of like code necessarily interjected by you, and all these structures that are pre-existing that we just kind of plug into, you know. And to me, I mean, I get excited about this kind of stuff because I just kind of like it. And I find it fascinating when somebody finds a new way to do things. Now, what I think is really kind of exciting too, and I say this to you guys because we're going to be introducing another programming language into our program next year, which is Python, right? And Python is a language that is very, very similar to Ruby. In fact, they kind of stem from similar origins, and they both have very similar features. Python, even more so, has the capability to tie into data in a much more rich way than Ruby even does. Yep, that's one of the more popular ones for that product. The last closing notes here is there are some things that we consider conventions in Ruby. Indenting two spaces. Spaces are preferred to tabs. You got that? Okay. Variables should be lowercase and underscored. So don't use camel casing, which is what you're typically used to. That's considered the proper way to do it in Ruby. Will it break? No. But that's considered convention. And then method definitions should include parentheses and no unnecessary spaces. That's true for databases too, right, Nathan? Yeah, don't put spaces in your database column names. That's just a rule of thumb. That works. That's pretty much true for every database, right? Use the underscore instead.
What I didn't realize up to now was including a new line.
Mhm.
And I was thinking that would not work. It didn't either.
It did. So every time you're iterating through a loop,
Right.
you're right. It does put an extra carriage return. Yeah, it does a new line thing at the end automatically. They're preferred to not be there. That's a better way to say it. So they really don't want you using tabs. I think you guys saw at the prompt. It doesn't really even matter if you indent two spaces. It still works. It's just considered, that's the Ruby convention. Okay. I would probably not look at your code and go, oh my God, you tabbed instead of spaced. You know, that's not the level at which I look at it. So that's just a convention that people in the language like to use.
I'm using Adam and it applies. So,
Yeah. And most good editors. You know, the other thing I'd like to point out to you guys, and maybe I did this very superficially initially, is there is a company called JetBrains, and you guys probably already know about them, I'm sure. They are very expensive. However, if you go to JetBrains and first thing you do before you start like downloading stuff is sign up for an account, use your student email account, so it's got a .edu at the end, and by virtue of that, they will give you free access to all of their products. Yeah. But that email account's got to stay active because every few months they ask you to refresh it. And then what they'll do is they'll send you a license key, and you can use that license key for all of their products. Their big product, their main product is IntelliJ, and IntelliJ, you know, it's intended to be a Java editor, but the truth is that all of their products somehow tie back to this one. So like if you use like WebStorm or PHPStorm or RubyMine, which is the one I'm pointing you to today, or IntelliJ, all those products are available inside there. There are some advantages to using the standalones because of the way that the updates are automatic in those for the sub products. But they do have a product. And I'm trying to find oh, here we go, tools, RubyMine, which is actually an editor designed for Ruby. So if you guys want to goof around with a high-level editor for Ruby on Rails, I would consider this the preeminent like IDE for Ruby. So do I use it? Frankly, no. But it is impressive. Do I use IntelliJ? Frankly, not really. Although I have it on my machine, you know, that kind of thing. You know, it's like one of those I always mean to but never do. And it's the same with WebStorm and PHPStorm. And I know, like, for example, Christian is real heavy on those products and shows them to his intro-level students. And you know what? That's great. And you guys should try different products. You shouldn't go with just the ones I point out. But here's one that you can get access to for free. So if you want to explore, go for it. I mean, they make beautiful coding editors. Right? That's a good way to look at it. All right. Last closing words here. If you guys are curious about the documentation, because I know that we were talking about it, I would assume that these links probably still work. Although, honestly, I would probably go to the Ruby language site and then look, for links to documentation from there. My honest opinion on it is, I think you'll find yourself looking so little at the documentation that it's probably pretty irrelevant. However, if you end up doing real development work in these languages professionally, you will then find yourself, obviously going to those repositories, especially if you're doing custom coding. But you got to remember, with web work, a lot of times we don't do a lot of custom coding. We do a lot of like putting things together and then putting a nice interface on it. That's right. That's a good way to look at it. All right, folks, that wraps the chapter. We're going to move on to the next chapter next week. And that is the database chapter. And this is the one that starts to put the fear of God into people a little bit because we spent 2 chapters on it. And there's some real challenges with this material if you don't read carefully. The advantage you have is if you follow along with me, I've done it enough times in this book, so I know where the read carefullies are, and I've highlighted most of them. But even so, I sometimes walk into the minefield too, unknowingly. But these are really important chapters because this is where we start to tie everything together with the database. All right, we'll see you all next week.